The Future of Software with Richard Campbell.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm serving companies that are building mission-critical software systems. Quick announcement, we are in the second full year of my architect forums. You can sign up for the next session online and link in the show notes. If you lead a software team and you're looking to collaborate with other peer software architects who are leading groups of software engineers, then this group could be for you. Sign up at the link in the show notes. And for those of you who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories, or on YouTube, you'll be able to find it. My returning guest today on the show is Richard Campbell, and he was last on show 133 talking about the history of .NET. But Richard Campbell wrote his first line of code in 1977. His career has spanned the computing industry, both on the hardware and software side, development, operations. He's also the co-founder of Strange Loop Networks, which was acquired by Radware in 2013. And he was on the board of directors of Telerik, which was acquired by Progress Software in 2014. And today, he's a consultant and advisor to a number of successful technology firms and is the founder and chairman of Humanitarian Toolbox, a public charity that builds open source software for disaster relief. And he also hosts 3 podcasts, .NET Rocks, which everybody knows about, for .NET developers, Run As Radio for IT professionals, and Windows Weekly. And we'll include a link to all 3 of those in the show notes. But Richard, welcome to the Azure DevOps Podcast again. How are you, sir?
It's good to be back, man. It has been a long time. And I think we first encountered each other on .NET Rocks. Weren't you driving truck for the Army?
Yes, way back in 2003.
Oh, man.
That's a long time ago. Well, you've been a host there for, how many dozens of years is that now?
I was a guest on an episode in 2004. And then Carl asked me to be co-host for show 100, which was in February of 2005. And that's right around the time that the word podcast got coined. Up until then, he'd just been making an internet audio talk show. So,
that's right.
Here we are. Like, it's literally 20 years ago now.
Well, you definitely finish what you start.
I was the third co-host, right? And the previous 2 each did 50 shows apiece, right? Mark and Rory each did 50 shows. And so I figured when he asked me to come on board at 100, it's like, I'll do 50 shows. What's the big deal? 1 a week. It's about a year. It'll be fun.
Right.
And what are we at? 1892. So missed it by that much.
That's a lot. Well, keep on going.
I got nothing to complain about. Like, when people ask me about podcasting, I'm like, hey, listen, don't do an infinite weekly. Make a season, make up a plan for like 24 or 50 shows or something, and then have a point of reconsideration, because you never know what you're signing up to. Not that I'm unhappy.
Yeah.
There's a reason I'm still doing this. I love the storytelling. I love thinking about what developers need to know in the next 3 to 6 months, and talking to the folks that are making the products and trying to help with that messaging. If I wasn't having this much fun, I'd stop, but I'm having a lot of fun.
That's a good point. I mean, everyone tries things, and then whatever fits to keep going. There's actually a lot of technology podcasts that have come and gone.
Sure,
and
absolutely.
For my side, I guess this one since 2018.
Yeah,
I love getting
6 years, man. That's a long time.
It's an excuse just to have a conversation with people like you. I mean,
true.
That's all I'm doing. And it's
Tell me the downside, right? Like, have you seen the people I've been able to talk to? It's extraordinary.
And actually, I read his book over 20 years ago. And I was able to talk to Kent Beck about test-driven development, having read his book 20 years ago.
The nicest guy, too. Isn't it crazy?
Yeah.
Just the nicest guy.
So there's going to be an upcoming, generation of people. Hey, I've been listening to podcasts for a long time. Should I start one? Well, the answer is yes. Give it a shot.
Always. Absolutely. Certainly, it's been my experience, 20 years of .NET Rocks, plus that we've been in people's heads since the beginning of their career, and then they come on as a guest. They hit a certain point in their career where they've got a story to tell. I reached out to them. I was like, hey, my name is Richard Campbell. I make this podcast, and I really appreciate the work you're doing. Like, oh, no, I know who you are. I'm like, okay, well, that's fun. That's great. So, like, why don't you come on and talk to us?
Right.
So that's a fun thing to be a part of someone's life that way, that you get to close that circle with them.
Right. And in your position, it's almost like when you say career mentor, like the career dad. Such a mentor. You see them progress.
I'm feeling granddadish these days. I'm pretty gray, but and I'm still out on the speaker circuit a fair bit, and I think I got 20 years on an awful lot of these speakers these days. Although I got to tell you, it is very nice to see a young group of excited educators just love what they're doing. Like they remind me of me 20 years ago, just so excited about what they're making, running with a group of folks that are all like, how's the best way to communicate this? Well, how do we do a great job? And I'm just delighted that it's happening.
Sure. And everyone tends to talk about the things that they are learning or the current perspective. And you have a lot of speakers talking about the new framework coming out, the new languages, the new tools.
True.
But you're speaking a lot about the history of .NET and philosophy and strategic architecture and projecting where things are going forward, because you've got such a broad perspective. What tends to be your common, topics these days that are resonating?
Well, I mean, everybody's freaking out about LLMs, and I'm tending towards the term large language model more than artificial intelligence, because artificial intelligence is such a bad term. Like, it's just not for many. I mean, we badly name things all the time, but this is extraordinarily bad, because it has such a legacy, right? Marvin Minsky, one of the early researchers in technology back in the 50s, coined the term to get funding from the U.S. military for what ultimately became the engine that ran your job back in 2003. The logistical engines of the U.S. military, the best in the world, and they were developed by these remarkable scientists in the 50s under the name artificial intelligence. But nobody knew that then. The first time you really see artificial intelligence in the public gestalt is Stanley Kubrick's 2001: A Space Odyssey. And then Hal tries to kill everybody. And so this meme, this mantra about what artificial intelligence means sinks into society through science fiction. Terminator, Jarvis, and Ultron. I mean, it's all the same meme over and over again. And then we decide to hang this on, well, we've used the term on technology several times. Like, here I am doing the history talk you always wondered if I was going to do, Jeff, right? Minsky's wave was fine, and it faded away as technology had to evolve a bit more. The next wave that gets coined artificial intelligence are the decision tree machines, Lisp machines, they call them. They were mini computers, about 50,000 a pop. And you would put in these instruction sets, essentially, if this, then that kind of mentality, right? Decision tree structures. But as soon as they got up to a certain size, they called them expert systems, the n over n minus 1 problem starts to kick off, and it gets slower and slower. And so it just becomes uneconomical to go forward on. Although fundamentally, that technology from the 70s is what creates Deep Blue in the 90s, the chess program that beat Kasparov.
And you said 50,000. That's almost $500,000 in today's dollars, somewhere in that neighborhood.
Yeah, and they only sold a few thousand of them. They're very expensive computers. They were difficult to program, and it was one of those things where once you got 80% of the way down the road, that last 20% was kind of impossible. And so another AI winter, as they term it. And then in the 80s, you got the first generation of neural nets. And a lot of that technology hit the wall with complexity as well. And this is where guys like Jeff Hinton, who are in the news today, really got their starts. So that's a guy who got his degree in this in the 70s, and he was teaching University of Toronto in the 80s. And he wrote this seminal paper where he essentially said, listen, we can't build deep neural nets right now. We don't have the computational power, but if we could, it would look like this, and we could use this adversarial training strategy. Like, he basically outlined the architecture of what would emerge in the 2010s in the 1980s. And that paper basically sat on the shelf until folks like Suskevar and others were, as students of Hinton's, started to implement it. They did it with the ImageNet competition. And very rapidly, Gen AI showed off its power. Like this generative model was really good at image. Remember when image recognition was impossible? And suddenly it was trivial. Yeah. Like instantly. This huge wave. And that is the wave arguably been riding ever since. Although when you talk to the scientists today, they largely say this algorithm has run its course from a science perspective. And so they're ready to move on and try other experiments, go in different directions. But I would argue this is like, you've figured out concrete. There's no more innovation to be done in concrete. Now the engineers can get to work and start building things with it. And that's where we land with the LLM. It's sort of the furthest we've been able to go with generative AI. And now we're starting to see these interesting language effects that open the door to some very interesting software. Although I would quickly say, and the talks I've done on this is like, this isn't the path to HAL or Ultron or AGI. Like, that's not what this is. And if you look at the real research in this space, you realize just how separate those two things are. Not that it isn't a powerful enough tool to do terrible harm to society, because it is. But it's not going to be a super intelligence that does that. It's going to be people abusing software.
Yeah. And it's called, artificial intelligence is so overloaded. I tell people it definitely is artificial. It's not intelligent. It's just, what's the probability that the next response would fit?
Yeah,
and it's wrong so many times.
And it just just tries, right? It's just a computational engine.
Yeah,
in two ways about that. And this is where, like, when someone pitches me as someone who does a lot of investing on an AI startup, it's like, the fact that you call it AI tells me you don't know anything. What technology are you using? Because artificial intelligence is the term you use when it doesn't work. As soon as it does work, it gets a new name. It becomes image recognition or predictive analytics or large language models. So while it doesn't have a name, it's just experiments.
Or adaptive cruise control. I mean, that was magic when that came out, right?
Yeah. Well, and if you don't listen to Elon and just focus on what the regular car companies have been doing with the software, adaptive cruise control has gotten very, very good.
Yes, absolutely. Where I intuitively trust it. I mean, because it's done the right thing so many times.
Yep. I don't know. And that's the thing, is that consistent behavior makes the difference, right? It doesn't slam on the brakes randomly, and it can keep in the lane. You're not asking it to do things it can't do.
Right.
That being said, I had a really remarkable experience up here on the coast in my friend's Model 3 with the quote unquote full driving experience, where it did get us from a driveway to a driveway.
Nice.
Over a 20-minute drive, always at the speed limit. Like, it was impressive. And it still felt unlikely. Like, I like that we're software people and we have some sense of how complex a task this is. And so we worried about it at all the right times. When the lines weren't clear, when the signs were bad, when the cars in front of us were doing weird things, each time we worried about it.
Well, it's always the exception case. And when everything's great, all our code works. But and this happened just a couple of weeks ago, I'm driving down the highway. I'm going 70 miles an hour, speed limit on the highway, four-lane highway, and several cars ahead, I see the 18-wheeler jackknife and go this and it's not the car in front of me, but I see something and I know, whoa, I need to get away from this situation.
Yeah, shut it back away now.
Yeah, what's the code doing? Is it locked in on just the car in front of me? I mean, that's a really complex dynamic just to be able to compensate for. We have split-second reactions.
Yeah, software in theory could have faster reactions, but we've certainly got enough. It could be good. It's just a really hard problem. And part of these neural net models is that they are not validatable, right? They're kind of a non-deterministic model because they're purely probabilistic. And so it's not only that you don't know when it fails, it's that when it does fail, you don't know why. And that is intolerable in many cases. For certain scopes of problems, you're just like, listen, I don't mind if you fumble the understanding of a phrase or you misrepresent a picture, but you're driving my car.
Right. Right.
And
well, there's a reason
non-determinism is just not good.
Before we get the autopilot, don't you think that we would have driverless freight trains first? They're on a controlled track.
Yep.
I mean, if there's anything as controlled an environment as that, but yet we still have drivers in every train.
Yes. And although they do have an autopilot and they use it a fair bit, but they're expected to be supervised by a person.
Right.
Which is just, that's the way the laws have come down. And I would argue the people to pay attention to are the heavy truck drivers and the heavy truck driving business, because for better or worse, the United States runs on heavy trucks.
That's right.
And that is the place where it would make the largest difference. Right now, a professional driver is only allowed 8 hours behind the wheel, 11 if they're not going to work the following day. And that means the rest of the time that truck is parked. And if you could turn that into 100% duty cycle, if you could now triple the utilization of a heavy truck, that's a significant reduction in cost for shipping. That's a direct economic benefit. That means everything that moves by truck costs less. And so if it's credible, if it's real, that's where it's going to appear. Even if it just handled the long haul part. Like I could imagine, don't let them in the city. You have yards on the outside of the cities, right? Handling yards for the goods. And these automated trucks pick up the load. And they just drive on the highway between yards. They do nothing else. The tripling of utilization of that alone. You're talking for low cost goods like produce that has to be cooled. The faster you can get there, the better, the higher quality product is, the lower spoilage. Like everything is better there. The price of a head of lettuce is more than half shipping. So you talk about reducing costs for people at a time when everybody's pretty sensitive to reducing costs. Like this would be a huge benefit. And the fact that we're not seeing big motion there already is a pretty clear sign of how far away this technology actually is.
Yeah, good point. Well, with so much you studied on history and seen the history, what other, you project it forward? What's the likely future? Are some of the areas more clearer than others?
Yeah, I mean, some things move slower, some things move faster. I mean, this is a famous quote. Gates is often referenced to, but it's actually an older computer science of this, that we always overestimate what we can do in 2 years and underestimate what we can do in 10. And so, people ask me, like, what is going to be wildly different next year? AI is going to change everything. I'm like, no. But 10 years from now, one of the things that's interesting when you start thinking about a large language model in this particular technology and in machine learning in general is that the voice interface has gotten wildly better. And it speaks to allowing people to understand less, to be able to describe things in a larger way of ways, and then spend more screen space on showing them what they need to know rather than building interface. So we could work on that path. But far more interesting to me is applying machine learning models behind the scenes. I'm surprised that we haven't already gone down this path. Most of our screens now have cameras in them. Why don't we have at least the camera using a machine model to identify sentiment? How is that person feeling? Are they frustrated? Are they struggling? Can we actually optimize the UX to help that user so that the inexperienced user gets more support and you can see that they're struggling and make it easier for them, simplify things? And as they get more experience, bring more features in? What if all UXs were dynamic? They were based on the individual's own ability to use it, own experience with it, so that we build up a data set of how that person prefers to interact with software because they can see how they're working. I've seen folks in the security space identify a person by how they move their mouse and how they type on the keyboard, because everybody has a fingerprint to that. So the idea that we could start to recognize folks that way, and then we could also recognize behavior that way, that you're struggling with the machine, you type and you act a different way. And when it's being productive, you act another way. That's all measurable. And so the machine should be more adaptive and responsive to us. That there's no new technology in that, really, Jeff. Like, that's stuff we already have. We just got to apply it. It's an engineering problem, and it's a solvable one.
Yeah.
And one that could actually significantly change the way people work with software.
That's a good point. We have fixed user interfaces, even going back to green screens, where we put in a screen code and then tab, and now we have point and click, a whole bunch of HTML screens running around. But
Yeah.
why do we have fixed user interfaces?
At the height of the MDA interface with the mouse fully engaged, we had a two-stage interface, right? The two-stage interface was the tooltip versus the shortcut. If you hover over that button with the mouse, you don't know what it does, a tooltip pops up to tell you what it does.
Mm-hmm.
But it also has an alt key. So if you're an expert and you've learned those alt keys, you don't even have to click on it. You don't have to take your hand off the keyboard, right?
Yeah.
So we learned to tie those dual interfaces together in there, much of which we lost moving the web, although you can put alt keys onto web pages if you want.
Yeah.
People just don't do it. And so when you start thinking about a dynamic interface where should I notice you're going at the, based on the data set of multiple people using this app, I can see you're going as fast as anybody can go. Your next logical thing is to learn some shortcut keys to go even faster. So now I could actually be prompting you to show you technique to improve your utilization of software.
Mm-hmm.
Like that's an interesting bit of thinking. And it comes down to, can we provide the data to developers about how people are using the software and build these optimization trees? Simplify when they struggle, optimize when they're moving quickly.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Well, I was going in for a physician, I don't know, it was dental exam, and 7 pages and disconnected forms, and they're all asking repetitive information. It's like, I already told you, my name is Jeffrey Palermo, my birth date is and I'm thinking it wouldn't be a hard engineering problem to have one of these large language models just save some context for the first time. This is who I am, basic information, and just, hey, autofill what is, boom.
Sure.
Autofill
and it was
the
on
basic
your,
stuff.
Browsers do this now. It's your machine, right?
Right.
And one would argue there's a whole privacy conversation going on here too. Tim Berners-Lee has had an initiative for a while to help to start moving towards more privacy. I shouldn't be typing any of that stuff in. I should be providing you with a token, which, by the way, has a limited duration that provides you with that information.
Yeah.
And so it's like, hey, for the duration of while I'm your patient, you have access to data. As soon as I leave, it goes away. For the, I would like to see that in the case of like e-commerce. For the duration of this sale, until the product is delivered and maybe out of warranty, you have access to my data. As soon as those things are gone, it goes away.
Mm-hmm.
Right? Tokens with limited time. And also would fix this stupid interface problem. Why are we repetitively doing any of these things? Now, I can imagine there were multiple forms because there's often multiple regulatory bodies affecting anything in healthcare, including dental.
Yeah.
And so it's like, hey, you need to fill in this form and this form and this form. No, 3 different entities, 3 different data sets, but they could all be using the same token.
Right. Now, do you think that voice interfaces are really feasible, or do you think that they're just generically too slow?
I mean, you make a break point is how often we can type faster than we can talk. At least some of us can. Voice interfaces are great until it fails the first time. Right? People don't mind talking to software unless somebody else can hear. And the moment you have to repeat yourself, you feel dumb. And so now you won't use it. Right? Like that's the reaction that people have to that. So it has to be good enough. Obviously, noisier spaces are not sound controlled spaces, problematic. Wake words, queuing systems, all of these have problems. So it's nowhere near good enough. And logically, it almost should be unnecessary. I use a voice interface to turn on the video lights for doing a stream like this, right? When we're online, it should know by what's in my calendar that I'm getting ready to stream and just turn the darn things on. Like, why do I need to do this? We haven't hooked these bits together. And even a gesture, there's many other ways to do this. So better awareness of software would help with all of that. And part of the problem I think that's holding a lot of this stuff back is the privacy element. we are loath to have cameras looking at us, even though they almost always are, because we're afraid of what will be done with the data. And that really comes down to we should have better controls over what happens to people's data, full stop. And if those things were in place, then it's like having the cameras watch you actually is in a lot of ways keeping you safe and making the world better for you, as long as the data is not abused.
Mm-hmm. So we've talked a lot about this current generation of the terrible word AI with the GPT, the large language model, but from the developer's perspective and in the future, we probably should just quickly answer the question: all right, am I going to have a development career, or is a computer going to start writing my code and my job is going to morph into something else?
Well, to be clear, we've always had automation, and we're only going to get more automation. And if your job was to write software, then you'd be in this career in the first place. Your job was to solve problems for people. And often you do that with code, but often you do it with libraries too, and software as a service and other platform pieces. Like if you don't make your own electricity either, right? So the fact that we have new tools coming into play that help us provide solutions to customers even faster is not a bad thing. It's a good thing. It's not like any of us was getting to the bottom of our to-do list anyway.
Right.
You talk to the old school sysadmins from 20 years ago as the cloud was coming into play. And what they were unhappy about is that they liked their days racking and stacking, right? They bought new machines. They were going to mount them in the racks themselves. And that was part of the fun for them. Cable layouts and network combing, like that was fun. And they were taking that fun part away. They still had work if they wanted to do it, because with the cloud, they had more time for preventative work, more time for deeper security structures, more time to work on things that matter to the business. So the same issue here with the developer. If you were in love with Flutter and building UIs, well, you don't even need large language models to threaten that. Go take a look at what Power Platform's doing for cross-platform clients with their no-code solutions, right? Where domain experts are jumping in and building clients that work on phone, tablet, and PC pretty much out of the box. So, you throw GitHub Copilot in here. Like we've got a couple of years with GitHub Copilot now. And I've talked to a bunch of teams where now the PM, it's not the dev saying, I love this, because they do. They've said that for a while. It's the PM saying, we're now 6 sprints in. Folks have gotten good with this tool, and the shape of how they produce code has changed. They check in more often. They also, one of the interesting stats that saw me is they revert more often. Now, they used to almost never revert. They just tinker and check in and check in and check in and check in. But now that you're using more generated code, they're firing in, looking and going, nope, and reverting that. And then starting over, working on it a bit harder. But for the most part, less bugs make it into production and more code's being written in less time. In the double digits, 25, 30% numbers are realistic here for the yield you're getting. Is that going to cost a developer a job? Maybe. And if I got 10 developers and they got a 25% performance increase, I might not have to hire another one for quite a while. But you still deal with the bigger issue, which is nobody's getting to the bottom of the to-do list. There's a lot of software to write.
Right. You're right. That changes the dynamics because if there's one situation, and for much of my career, all my coworkers, did this as well. You have code, and then you modify the code. So you have to read it multiple times to figure out where you're going to modify it. But this generate little snippets actually encourages more object-oriented segmentation so that you just have a structure. And then within one code file, okay, we're going to generate this. And if it's not the way you want it, let's just get rid of it and let's write another implementation of that.
Yep. Well, I mean, you used to see this when Stack Overflow was new and young and fresh. People were picking up code out of Stack Overflow and firing it in as well, and they revert. And that behavior largely ended. So I wonder if we're also in the early days of GitHub Copilot. And so folks are not quite sure the right way to use this, but they know enough to know, I can roll back. That's fine. And tinker again. It's going to take a few more years to really polish this up. In the meantime, it's a moving target too. What we haven't seen yet, but there's no reason this shouldn't work, is a large language model that looks over all of the projects in your organization and now can derive coding style by what it's actually found there. That we may spend more time describing our solution into the system so it can find existing classes, existing data structures, things we should have been doing but are too difficult right now that the tool should be much better at. We should get to a point where we have pattern detection, where it's like, hey, sure, it looks like you're building out a factory here that follows these rules. Let me help you refactor. We're just too early. A couple of years from now, those ones sort of fall out naturally.
Do you remember the time early on when you would spend an entire day just trying to get something technical working? I sure do, like scouring the documentation. It's like, how do I get this thing to connect?
Yeah. And reading the books. I had the wall of books, and it's like they're full of Post-it notes, right? And so I'm sort of thumbing through trying to find like, why is this not behaving? And then eventually I had access to CompuServe, and that was sort of the first place where I could find like-minded people that were struggling with same problems, and we were on those forums, before the internet became public, and we had access to more and more people.
I would love to be the 18-year-old me in my first coding job with GitHub Copilot. I would love that.
Yeah. I mean, and part of that is just the fearlessness too. It's just like, let's just try stuff and get out there, and hopefully our architects have built good enough safety rails around that young person so that when they go off the reservation, because they're gonna, at least they bump against a test infrastructure or, a pre-prod environment or something that allows them to make mistakes without significant consequences to the organization. I mean, that's our job when we lead teams, is to give room for the new folks to experiment successfully.
Well, there's so many software organizations today that do have software managers and a whole chain of leadership, but it seems like there are even more companies now that were like the company that hired 18-year-old Jeffrey, where it was just me writing code. And yes, there was a manager, but it's not like it was I mean, there's tons of organizations that like they hire somebody and there's no process, there's no guardrails. There's like, oh, you know how to write code. Okay, can you do this?
Yeah. And I think it is an interesting problem. And for those folks, it's like, there are better tools for you in those scenarios. Like that is where a low code solution makes an awful lot of sense, where the risks are simply lower. If anything, you're going to run into barriers to the sophistication of the tool for what you want to do versus you're going to write stuff that makes a terrible mess or causes harm to the organization. Most organizations are not that sophisticated, and the market seems to be compensating for that. This wave of Power Platform and their like reminds me a lot of Access in VB in the early 90s. Just the beginning of, can I have a safe way to write software again? And they're being mocked the same way that the VB and Access people were being mocked back. That's not real programming.
Right.
Yeah,
where's the code? Where's the code?
Heard that one before. Like that. This pattern is familiar to me. And yet, the same thing happens. Those folks cry all the way to the bank because they deliver solutions quickly that are sufficient to the task.
That's a good point. Sufficient. Because, I mean, you could say the same criticisms. What does a test environment look like for this? How do I simulate? I mean, it's kind of all the same limitations too.
Yeah. And there are answers to all those questions if you choose to look. They're not the same as the way you would do it or you worked hard to learn. There's always this question of, are all these battle scars wisdom, or are they actually holding you back?
Habits. Yeah, habits instead of wisdom.
Yeah, and that's a trap we get into. Another wave of tooling has come along. Yes, it has limitations, but is it sufficient to the task? You got to take it out for a spin to know. And also get back to, especially in the case of like Power Platform, where are they? V2, maybe V3? Like these are still early days. So, you look now and go, no, there's a barrier. Put it on a 6-month wait list. We'll look again when the next version comes along the path.
Yeah. There was a pattern, I guess it was in my university education, and it seems like it still applies. I'll get your take on it. The separation between a system of record and a system of interaction. When I think of like Power Platform, some other things, really great at systems interaction, but that some number of years, systems of interaction, they're going to be replaced with the next one. But when you have a system of record that has the database, the core of that, it's like a multi-decade, lifespan.
Sure. And This is where I think the folks at Power Platform have done a good job, because in general, that system interaction is the client app that you're building, the Canvas app or whatever else you want to use. But behind that are still the same old data stores, moved to the cloud now, right? They're Azure SQL, but also, hey, we shifted our sales process over to Salesforce. Well, there's a Logic App plugin that it can call to. So you're just connecting those pieces together. Stuff that used to be a lot of code now is a pretty simple piece. So they've steered clear of messing with those systems of record as much as possible, and made it pretty simple that where you don't have a good interface, this is where a traditional developer or a back-end developer can step in and say, oh, I can build a set of interfaces that present this to our systems of interaction folks so that they can take that forward and make it available to the user.
Well, as we get to our time here, kind of one more futures question for you. In your sense of the segmentation of our industry, or what seems to appear like the segmentation, like you've got people where the tool belt is full of JavaScript and Node tools, and then .NET, and then this technology, that technology, and all the different segmentations. And where do you sit with that when guiding young developers for where to focus? Is it the industry is so massive you pick one and you're never going to be out of work, or are there some major segmentations that you've noticed that seem to have some traction going forward?
Yeah, I think rule number one is we're all polyglot. You are never going to only program in one language throughout your career. Start with one to get comfortable, but you're going to add others, and they may be complementary, like C# and SQL, two different languages, but definitely work together in an app, and having skills in both are useful. There's a reason there's a diversity of languages. There's a diversity of need and a diversity of skill. And so we continue to allow those things to be broad. There are complex functional languages that are incredibly good at backend services, like an Erlang. That's an interesting way to think, and people have built extraordinary things with it, but it is challenging to work in, and it has its own aspects to it. So worth pursuing that if that's something you fall in love with. I wouldn't call it a first-timer's language. There's easier ways to get started. That's I've reached a certain place where I was trying to build good back-end bits with a different language, and then ran into some issues with scale. And somebody said, hey, have you looked at this in Erlang? And now I'm a domain expert. I know the problem space well. So now I'm approaching the language with, how do you address multiple reentrancy? And these other issues that I was struggling with my general purpose language. I wouldn't call Erlang a general purpose language. It's much more specific. And we see new languages emerging occasionally when this happens. Although I would say right now we're in a lull again. They divert. There was a few years there where we cranked through quite a few languages, and they were mostly to do with responding to good cloud behavior. You look at languages like Go and Rust, and even the Erlang is older. It certainly had an ascendancy in this environment because suddenly a lot more of us were thinking because of cloud in this complex way. I would argue that the next wave of new language will appear as augmented reality becomes a viable product. And we need languages that better describe user interfaces and interactions in an augmented reality way. Not that we found our way forward yet. I think what Apple's built with the Vision Pro is a beautiful piece of hardware that doesn't have a problem space. Till someone shows me information worker advantage through an augmented reality interface, I'm going to have a tough time with this. Right now, it's winning in verticals. You look at where HoloLens has won certain expensive verticals because they're expensive hardware with expensive run times. So when you're doing a $5 million service on a $50 million jet engine, $5,000 headsets make total sense.
Right.
But, PCs became PCs because of the spreadsheet. That was the thing that a regular information worker looked at and said, that beats the hell out of graph paper and a calculator. I want that. And that made the PC on every desk thing come true. And then it morphed from there. Today, we can't imagine not working with a PC on our desk or a PC in our pocket.
Yeah.
What's the interface advantage that augmented reality is going to take on that? And that will open the door to, then we'll need better languages for it. But first, we have to solve the particular problem space. And we started this conversation on generative AI and those kinds of models. Like, I wonder if those things aren't going to intersect to change the way we look at interfaces entirely. As we move away from, let's face it, screen, keyboard, mouse in variations. Touch is just a variation of mouse. Has been the UX for compute now for decades. We're pretty ripe for a change. Okay? We've done the important thing with phones. We've now made that the principal personal device, something you carry on you. Pretty much every adult human on this planet has access to one. You know, it may be you in a developed Western world playing Candy Crush on it, but to a Ugandan farmer, his discount Android phone, discount from my perspective, was still a big deal for him to have, tells him when to plant, tells him what blights are in the area, makes the difference between his family eats or doesn't. You know, but it's still the smartphone revolution and the internet revolution that's made that come true. And arguably augmented reality is the only thing I've seen that could disrupt the smartphone, could actually take us to a level, because it can do everything the smartphone does and more, but only as it gets good enough. And as we find that hook, what's the thing it does better than any other way that would make it make sense for us to take it further? Not going to be social media. Sorry, Meta. You know, and it's not going to be just a lifestyle device. Sorry, Apple. Right? It's got to be something mainstream that says, "Oh no, my company has a competitive advantage when my folks interact this way, and that's enough for me to go forward on that." And that, you know, how do you pick a language now? Thinking that way. Again, you can almost not go wrong. The top 5 or even top 10 all have work. As much as you can do and more. You got to find the one that makes you happy. Like where do you enjoy programming? What are the problems that it tends to address that are problems you enjoy addressing? You know, the real challenge here when I'm talking to a young developer is they haven't found the part of development they're in love with yet. They're just at the beginning. They're just dating. And so it's like, you need to try some things. You got to get out there. And so don't get too hooked on any one language, because if you confine your work to the language you pick the first time, you may be missing out on a great love, something that'll be extraordinary for you in the future. So take what you've learned so far, apply it somewhere else. You know, the brilliance of things like katas, just programming exercises. Initially work in the language you know, go through a few katas. It's not an emotional thing. You're doing a simple task. Then try katas in your language, but with a restriction. Don't use any if statements or any loops. Press against the edges of your ability. Then try switching a language. Now, how would you approach it? And that breaks your mind out of any given programming language's way of thinking and into the broader solution mindset that says, how do I solve this problem? Here's an array of tools. It makes you a better developer, and it opens your mind to different ways to think about problems so that you can go further with stuff. You can explore different solution sets and might find a place for you in this industry.
I like that point. It reminds me of just playing instruments and musicians. If I was a musician and I only ever touched my instrument when I was on a paid gig, getting paid for actually playing on stage, and I just filled my calendar with paid gigs and never touched the instrument except when I was getting paid, I'd be in a rut. But real musicians, they touch their instrument and they just do little jams and practice all the time, not just the hours they're getting paid.
Well, and also don't just play their own songs, right? When they have a choice to play, the one thing they don't do is the thing they get paid for doing. They experiment on the edges. And, this relationship in music and programming, we've talked about over and over again over the years, because like music, programming has no end. It's a mastery problem. It could always be better. You can always press against the edges of your skill further. Like there's no certainty in any of that. And every problem has its own entertainment. The creating is where the joy actually lies. It's just a question of what you need to create at the time. What are you going to get paid for? What do you enjoy? Where's your love lie? And part of that can be experimenting with different tools in different ways.
Yes, sir. Yes, sir. Well, hey, we're at our time. I'd love to go on for another 17 hours, but it's so good to have you back on the Azure DevOps podcast.
It might have been too long there, Jeff. We should probably make this a little more often.
Absolutely. Thanks so much. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.